In this part, we're going to talk about how to use the Excel solver to solve the linear programming problems. So before talking about this Excel solver, I want to show you how to load the solver into Excel. You can Google it. For example, you just use the keywords like load the solver, adding in Excel, and then you can find this the page, right? This the from Office support at the Microsoft website. You can uh, know how to add the solver into Excel. For different operating systems, so they have different steps. For example, if you are using the Mac operating system, so you can follow these steps. The first of all, you need to go to the Tools menu, select Excel add-ins. Number two, in the add-ins available box, select the solver add-ins checkbox, and then click OK. If the solver add-ins is not listed in the add-ins available box, click Browse to locate the add-in. If you get a prompt that the solver add-ins is not currently installed on your computer, click Yes in the dialog box to install it. Right? And then you can go to the Data tab, and then you can find the solver. This is for the Mac operating system. But how about the Windows? If you use Windows, you should make sure you're using Excel 2010 or later version. You go to the File option, right? Here, you can look here, right? And then you click on Add-ins, okay? Then in the Manager bar, select Excel Add-ins. Click Go. In the Add-ins available bar, select the Solver Add-ins. Check the box and then click OK. The same thing, you just need to go to the solver, go to the, if you want to access solver, just go to Data tab, and then you can see the solver to the right. Okay. So you should make sure you add the solver into the Excel before we learn about the computer solutions approach. Now let's go back to the lecture. So in this part, we're going to use an Excel solver to solve linear programming problems, right? So we can use this solver to solve linear programming problems, integer programming problems, non-integer programming problems. But also there are some limitations for this solver. So you can solve up to 200 variables, and also in some situation you can solve up to 100 constraints. But if you want to solve more complicated linear programming problems, you should refer to other computerized software packages. For example, like CPLEX. You can use the CPLEX, right? There's CPLEX, IBM CPLEX, right? All right, so next we're gonna show you how to use the solver. We're gonna start with the maximatization problem, the furniture example. All right, so we know this formulation already. This objective function and the constraints, but here we don't show you the non-negativity constraints, but we assume you know, okay, T and C must be non-negative. But how to formulate this problem in Excel solver? Okay, we do it this way. We follow the first step. We needed to enter the problem data. Okay, we need to define these different variables, okay, and assign the cells to different variables, and write down all the coefficients of objective functions and all the constraints, the right-hand side of values, all the things. Right, this is about the data. We call this is data section, and then we needed to write the formulas. This is about the model fraction, and then we can solve the problem using solver. This the input, right? Like this. The first of all, we should give a name, like the Flair furniture as a name, and then we needed to write down variables, the two different variables, T and C. One is the designate the two cells, this one, two, the two cells to decision variables, because you need to let the computers know you needed to assign two cells for decision variables, because the values in these two cells, well, will change. Right, so this is why we want to do this. And then we needed to write down updated function in terms of decision variables. So we know the unit price for a table is $70. The unit price for a chair is $50. So we put the 70 to 50 right there, and then we're going to write the profit. So here you should use the formula, because what's the formula for profit? So we needed to add the total profit for producing T tables and the total profit for producing C tables together. And this is the 70 times T plus 50 times C. So here you need to write this formula. And then you need to write down all the constraints, right? The first one is the common-tree constraints. We have some the numbers here, 4, 3, 2, 1. And you need to write down the left-hand side, because there are formulas for left-hand side of constraints. So here, the formula should be 4 times T plus 3 times C. And for depending on the constraint, the 2 times T plus 1 times C are less than or equal to the right-hand side of constraints, the 240 and 100. So this the data section and the model section. Basically, we wrote the formulas for profit, the left-hand side and the right-hand side of constraints. Right? And also we input the data into the Excel spreadsheet. Next, we're going to solve this model. We need to set up the solver and solve this problem, and then we can get to the ultimate solution. It's very easy to use. It's very quick to get the ultimate solution. Here are the formulas. Okay, so I want to introduce this function in the Excel called sum product. Basically, you just need to select these two rows or two columns, and then they can do the calculations. The first of all, they do the multiplication. Right? For example, you just select this row, and then the next row. Okay, and then you can calculate the profit. So the sum product, the first step is this product, the multiply, right? The numbers, right? Cell by cell, and then they do the summation, add them up. So this is the sum product function in the Excel. The same thing, you can use this function to calculate the left-hand side and right left-hand side of the constraints, like this. Okay, and then you needed to give initial values for different variables because this is very important, initial values. So this is a very important step. We put a 1, 1 right there, and later on we're going to use solver to solve the problem, and you can see the different the values for T and the C. And so we're going to start the solver. But how to find the solver, you need to go to the data tab, and then you go to the right, you can see the solver, right? And then just click on the solver, and then you can see something pop up like this, right? So this is the solver, right? The first one, you can see the set objective. This is the profit formula. You just select the cell, right? And cell, and then you need to choose to maximize or minimize, because this is the flat furniture example. We like to maximize the total profit, and so that's why we should do the max. Right? The second step. This one is about select decision variables, because we like them to change and then to find the optimal solutions. So we need to select all the decision variables together. Right? And the next step, we needed to add all the constraints. You can see the add button and the change. If you added some constraints, but you want to make some changes. For example, you may find some errors, you want to make changes, you can just change button. And or you want to delete the some constraints, okay, you can delete or reset all, right? All, but also you can use some the files, the load file, okay, to process constraint in a batch. But for our examples, I don't need to use a load save button, right? We just use add, change, delete, or reset all and options. And okay, so later on we can add them, but you should make sure you already wrote the left hand side and the right hand side of constraints, right? So you just click on add a button so we can add all the constraints, okay? But for the solver, we need to do it one by one, right? So let's look at the cell reference. This is about the left hand side of the constraint, right? When we look at the coverage constraint, so this is the left hand side. And then you need to double check this sign here, because this is about a furniture example, so we use less than equal to sign. But absolutely, there are other the kind of signs available. For example, equal sign, greater than equal to sign, or other kind of signs, right? And then the constraints. This is the right hand side of the constraint. The constraints. You can select all the right hand side like this, right hand side like this, or left hand side like this, put them together and just click on the button. Also, you can add one by one, right? Okay, and then you should go back to this part. So check this box for non-negative variables. So make and constrain variables non-negative. That's very important. Uh, the part, you have to check this box, otherwise you get a problem. And then you need to select the solving method. You should choose the simplex LP. The default, the method is nonlinear method, but we don't use a nonlinear because it's a linear. So we have to switch to the simplex LP. So when you try to solve this model, you should be careful with these two options. But also, before you click on the solver, double check this method, right? Double check, and then click on the solve button, and then you can see, right? Something like this. You get a message: the solver, the found the solution, right? To keep the solver solution, right? Then you can click on open button, and then you're gonna see the results, right? So 30 and 40. We already got these two numbers when we try to use the graphical solution approach. So this is about computer solution. And this is about how to use Excel solver to solve a maximization problem. But how about the minimization problem? So the same thing, we needed to give a name and define decision variables and designate the cells for each decision variable. And then we needed to write it down the coefficients of objective function. Then we needed to write down the cost formula in terms of decision variables. Then we needed to enter the data here and then write down left-hand side of each constraint. Okay, this is because they are formulas, so we need to use these variables. And then we needed to give the right-hand side of the constraints. So just about the data section and the model section. When they're ready, we're going to open the solver to solve this minimization problem. So here are the formulas for cost for left-hand side of constraints. So the same thing, we can use the sum product function in the Excel. And then we can get all the formulas and we open. Then we're gonna open the Excel solver and follow the step as the mathematician problem for using the solver, and then we can solve this problem. Absolutely, you can do sensitivity analysis, but how to do sensitivity analysis? For example, we're gonna look at this part. You can see here, so the report, we have answer report, sensitivity and analysis report. You just click on the sensitivity analysis report, and then you can get a sensitivity analysis result. And based on the result, you can do further analysis on the parameters and to know the ranges as well. So now I'm going to show you how to find the ranges when we try to do sensitivity analysis. Now we're gonna show you how to do sensitivity analysis. You need to download this Excel file from my courses. I already posted on my courses, so you can download it. And then you can see this is the maximization problem and this is the minimization problem. So I'm gonna use the maximization problem to show you how to do sensitivity analysis. So first of all, you need to add the solver into Excel. You can go to the tools. You can find Excel add-ins. Then you're gonna choose solver add-ins to check it. I have to check it. But I'm using the Mac operating system. If you are using the Windows, you should follow the something I showed you previously, and then to load Excel load Excel server, and then you can use the solver to do sensitivity analysis. And then click on OK button. Right? After this, you need to go to the Data tab, and then to the right, then you're gonna find the solver like this. Okay, so before going to do sensitivity analysis, you need to make sure you have everything right. So for example, here you need to check this one to make an unconstrained variables non-negative, and also you need to switch to simplest LP method. Right now, we are ready to click on the solve button. Then you get this one. You tell them to a message. The solver found the solution, all the constraints and abnormalities conditions are satisfied. Now you click on the sensitivity. You can look at the report and click on sensitivity, and then click on the OK button. And then you're gonna see sensitivity report one. Click on it. You're gonna see this report. This is the way we perform sensitivity analysis. Now I'm going to show you the first two types of sensitivity analysis. So we're going to look at coefficients of objective function and also right-hand side of constraints. Here from this report, you can see the optimal solution, the 30, 40, and also you can know objective coefficients here, the 70, the 50. Now you can change the current table prices or the chair prices from you can change the price from 70 to 70 plus 30. That will be 100. Also, you can reduce the current price of table from 70 to 70 minus 3.303. You can run 3 up, okay, to 4 or or run it down to the 3. So if I run it down to the 3, that would be 70 minus 3, that would be 67. So you can find this range from 67 to the 100. So this is the range. If the new table price fall into this range, so you can say the ultimate solution doesn't change. So it is deal 30, 40. Also, you can change the share price. Current share price is 50. You can increase share price to 50 plus 2.5. This is the 52.5. Also, you can reduce share price from 50 to the 50 minus 15. So that would be 35. So this range for the share price change would be 35 and 52.5. So in any, so in other words, any values in this range will not affect the ultimate solution. So we still have the same ultimate solution. This is why we like sensitivity analysis. And then let's look at the right-hand side of constraints. The current right-hand side value is 240, and the one more is 100. Now you can increase to 240 because this is about resources. You can increase resources and also you can reduce resources. For example, if we want to increase resources, right, so what's the upper limit? So 240 plus 60 is 300. And also we can reduce right-hand side of constraints, so the 240 minus 40, so it's 200. So the range is 200 and 300. In other words, if you add or you want to change the new resources in the carpentry department, for example, you want to increase the time that will be available in the carpentry department. So if this new available hours fall into this range from 200 to 300, so there will be no change in the final values of T and C. In other words, so the ultimate solution doesn't change. The same thing for right-hand side of a second constraint. So this is about the pending and the wanting constraints. You can increase available hours in this department from 100 to 120, and also you can reduce available hours in this department from 100 to 80. So the range is 80 and 120. So any number in this range will not affect the ultimate solution. But beyond those ranges, so we cannot say we're gonna have the same optimal solution, but also we cannot say this ultimate solution will change. So the ultimate solution may or may not change beyond those ranges we just figured out. So this is sensitivity analysis.